Hello, and welcome to today's webinar. Today we'll be discussing the deployment and management of containers with Kubernetes. My name is Kirill Dabrowski. My title is Principal Solutions Architect here at Mission. And I'm going to dive right in. So you may want to get Kubernetes into your organization, and we have the talking points to help with that effort. We'll review containers, Kubernetes, EKS, Elastic Kubernetes service inside of Amazon, and why you may want to use it. We'll go over the overview of Kubernetes, the services and components, and how to manage and configure containers with Kubernetes and AWS. We'll do a case study example and do some Q&A at the end. Just to let you know, we're not sponsored or partnered with Kubernetes. We're just big fans. Feel free to pop questions into the chat as we go in the sidebar of the BrightTalk app, or if you have a more detailed set of questions or a scenario you may need help with, Mission offers a free hour of consulting that we call Solutions Architect on Demand, and we could try to get you some more detailed answers during that session. The questions you post in the BrightTalk app will not go out to the attendees, so feel free to ask away. I'll do my best to talk slowly today. I do like my coffee, so I may talk, go a little fast. And I'm also used to interactive conversations, and since the BrightTalk app won't allow you to interrupt me, I'll do my best to answer all the questions at the end of the presentation. If you notice in the BrightTalk app, there are 3 attachments. The first is some more detail around that free AWS Solutions Architect Consulting program that I mentioned, that Mission provides. There's also a containers overview, as well as a case study for YourCall Football that we'll review towards the end of this presentation. If you're here, you probably don't need to be sold on the benefits of containers. It's a great way to achieve a wide set of efficiencies related to scaling, performance, and cost, not to mention speed to market of functional changes. Also, in today's hiring market, developers or SREs trying to support or to try to hire those folks into supporting a monolith or on-prem application can be a challenge. So getting to a modern technology like Kubernetes is going to help in that effort. If you're trying to choose a platform, or if you've already started running your containers somewhere else, I'll go through some of the reasons why you should choose Kubernetes. I started working with Unix container technologies with Solaris Zones back in 2004, and although the container technologies is similar today, the management orchestration tools are just so much better with today's tooling like Kubernetes. When I started diving in and trying to learn Kubernetes, I was overwhelmed by just the seemingly clockwork functions of all of the inner workings and services and functions that are required to get a Kubernetes clusters to run. I wanted to know all of those inner workings. So we wanted to name this webinar Demystifying Kubernetes, but we found that there's a lot of those blogs and webinars out there. So we probably won't be able to get to all of your questions today, but hopefully it gets you on the right path. Kubernetes is self-healing. So unlike a clock, if a gear breaks, that component will be killed off and replaced if set up properly. We'll try to give you the information to get you up and running quickly and to get you started with Kubernetes. So these are some of those bullets I mentioned to help you sell it internally in your organization, the business case. So all of these things mentioned here: improve scalability, performance, resiliency, availability, added efficiency, operability, and better security and cost benefits are all what becoming cloud native means. You're no longer running hardware. You've moved your VMs into the cloud. You don't want apps sitting idle, wasting compute hours and the cost that consumes. You need to be able to make changes faster, and you need multiple layers of resiliency. Becoming cloud native is a mechanism to perform those efficiencies and gains. So how to get there, right? Orchestrating containers or serverless applications in microservices is the quick answer. Kubernetes is the shortcut to becoming cloud native. Containers are effectively a gateway drug towards serverless technology. But I like the movie What About Bob and using baby steps and not trying to boil the ocean. I always recommend not forcing adoption. So monolith applications, for example, sometimes need to be carved apart carefully and slowly into microservices in order to gain those efficiencies over time. But you can set up Kubernetes, install your containers if you already have them set up, and tell your investors or boss that your infrastructure is cloud native without lying. The 12-factor development guide linked here in the bottom is an excellent source for helping architect into microservices. And you can find where you are along the path towards a cloud native architecture at that Cloud Native Computing Foundation GitHub link there. And now we'll dig into the Kubernetes components here. So this diagram depicts just some of the controllers and functions. So the API is how the kubectl interfaces with the services. The etcd service is the name value store used by everything. The schedulers and controllers decide what is running and where to put objects. The overlay network is the network space internal to the cluster. Worker nodes are where your containers run. The kubelet is a container that runs on all of the worker nodes. The cAdvisor and proxy are some example add-ons that expose services as the proxy does and gather metrics with the cAdvisor. Some other add-ons that we often use are FluentD for logging and Heapster for additional metrics. But we'll talk about some of those later. Last thing before moving on, I really like talking about this slide because we no longer need to know or worry about the top half of this diagram with the introduction of EKS. So introducing the Amazon Elastic Container Service for Kubernetes, Amazon EKS. Makes it easy to deploy, manage, and scale containerized applications using Kubernetes. And you no longer need to worry about, again, all those interworkings of the services required to manage and scale the cluster. And you can just create that cluster control plane in the console or with a command line and EC2 workers that will allow you to start deploying containers. And now I'm going to talk about how, right? So the simple cluster creation is relatively straightforward compared to some of the other services I've tried to use in the past. It's 4 quick steps. We do this all with Terraform mostly when we're deploying this for our customers, but you need to create the network, the VPC, which, dedicating a VPC to EKS cluster is a good idea because the EKS service uses tons of IPs by setting up the max amount of elastic network interfaces or ENIs on each worker node at scale. Then you need to create that EKS cluster and the worker nodes auto scaling group. We do those first 3 again with Terraform, but then you need to run the config map, which is deployed with kubectl, to basically link up the worker nodes with the EKS cluster control plane. There's now an even easier way, and that's depicted here in this shell, where there's a single command line, EKS-CTL, which can create the cluster and all of those things mentioned in those 4 steps in one quick command line. You can see that I'm running EKS-CTL, create cluster, naming it my Kate's cluster, and the version of Kubernetes I want to use, how many nodes or worker nodes I'm going to run, and the max. And then some additional flags that I like to set to allow for additional functionality. At the bottom of this, it spits out a number of things that it's creating, but towards the end is the kubectl command that you need to specify the kube config, or in your .cube/config is the default, which contains the API key in order to access the Kubernetes interface with that kubectl command. The kubectl command, I spent a long time, again, learning all the components from the ground up and trying to get my head around how this whole thing works together. But when I finally got to start playing with the kubectl command, that was my aha moment. That is where all of the fun happens. And the Certified Kubernetes Administrator exam is all about this command line. As you can see in this shell, I created objects using a YAML file that set up a deployment of containers, or pod, which is a set of containers. And I'll talk about the contents of that YAML in the next slide. Then you can see I issued some get commands to see the deployment. I issued kubectl get deployments to see that portion. Then get pods, the running pods that are in the status running. I'm getting the nodes, so you can see that there's 2 instances, or EC2 instances running, and that's their IP and the version. And then I do a get services of getting the services that was created with that Nginx YAML file at the beginning. Let's see. So there's quite a long list of additional options with the kubectl command, as it is rather powerful. You can update objects, patch, edit, scale, SSH, or interact with pods, nodes, and clusters. And make sure to set up autocomplete in your shell, as it makes things a lot easier. Now we'll move on to the manifest, or that Nginx YAML that I mentioned. Everything in Kubernetes that you're deploying is defined with YAML and the objects therein. First, you need to specify what kind of thing or object that you're going to need to set up. And in this first instance, we're using a deployment. This is a relatively simple setup with a quick Nginx web service and a load balancer. To give you an example of how quick and easy to set this up is. First, the kind of objects to create. Since we need to launch the image of our container first, we're doing a deployment here for stateless containers. There's some other types of container image creations. You could use the less common stateful sets instead of deployment when you need persistent volumes, for example, or daemon sets, which only run 1 pod on every worker node, and only 1. Logging and monitoring are common examples of daemon sets. Or there's also jobs, which will run a set of pods until completion and report their success or failure. And there's also cron jobs type, which can be scheduled. Then there's the namespace. This is intended for use in environments with many users or projects within a cluster for organizational reasons mainly. Most often, the default namespace is used, which is called default. I've found labels to be a lot more useful than splitting things out by namespace, as they could be modified and used for other purposes. Labels are like a release type, so think of canary or stable, or the environment, dev or prod, or the tier or customer name. They can also be used for node affinity. So that means you want to, for example, tie certain containers to run on certain EC2 worker nodes. So you can have multiple auto-scaling groups supporting different types of containers by using that labeling and node affinity. Then there's the image specification. This is an ECR repo ARN. Some items missing that are commonly used in the deployment YAML block are image pull policy, which is something you can put right after that image flag. And that, for example, you may want to pull the latest version of that image every time if you're using a different scheme for your image tags in the ECR repo. Environment variables are also something that we most commonly see here, which are a set of name value pairs that get applied to the containers that are effectively, OS environment variables inside the container itself. We also use liveness and readiness frequently, which are extra validations you can use to monitor the functionality of the container. And Kubernetes will cycle that pod if those tests are failing. You'll notice the replicas line in that spec in the top section here. That's set to 1. And as you saw in the previous section, I only had one container running. That's not correct. So this is a web service. I also obviously need it to be redundant. So we can change that later with another kubectl command to create an auto-scaling group of containers, or what is called an HPA, or a horizontal pod autoscaler. The second portion of this YAML file you can see is a kind of service. That means that I want to expose networking, which obviously I need the internet to get to this Nginx web service. I'm randomly choosing a node port to apply that will listen inside of the worker nodes, and the load balancer will talk to that node port and distribute the load internally and exposing port 443 externally. And the type here again is load balancer, so that means that it's going to actually create a Amazon ELB in this case, but that can also be an LB in the newer version of Kubernetes. So now we'll talk about some scaling options. I mentioned that HPA, or horizontal pod autoscaler. That triggers on CPU by default, but it can be triggered on external resources like a queue, for example. If you've built the worker nodes with EKSCTL or the example CloudFormation template, you'll need to create an auto-scaling trigger to scale up and down those EC2 worker nodes specific to your workload bottlenecks, like memory, for example, or latency. But really, any CloudWatch metric can be used to scale those workers. The metric server can do even more internal monitoring and triggering for HPAs. I mentioned Heapster, which is another metrics container that we often use and deploy quickly that can gather similar style of information. The dashboard here is a handy tool that you do need to install and configure with a deployment YAML that's quick to download and deploy. And that's a screenshot of what that looks like. Then there's also Prometheus is another monitoring tool that we often see. This comes down to your own personal preference and maybe experience, but if you want to get started quickly, Prometheus is a great product that's open source. If you are already invested in something like New Relic or Datadog, those come with great monitoring hooks into the Kubernetes infrastructure. The CNI metrics helper is something I mentioned here because CloudWatch metrics for the EKS inner workings are not available out of the box, and so there's an additional setup that you can deploy for the CNI metrics helper. And streaming logs is also something that I wanted to mention on this slide because that can also drive monitoring, and we use FluentD primarily for that, but there's a number of other basically streaming services, and that you can send your logs into your favorite log aggregator tool like a Sumo Logic or Splunk. Now we'll dive into some continuous integration strategies. You can automate deployments with the kubectl command with HPAs and rolling updates, but if you want to have more flexibility, Helm is the command line and Tiller is the service that runs inside Kubernetes, and we found this to be a very powerful tool to help you with your continuous integration strategy. So you don't need to hard code, for example, a bunch of stuff into that YAML file as I showed you previously. Helm allows you to parameterize those values like the image, number of replicas, for example, or really anything else that you want to variabilize in those deployments. Some of the strategies that we've used in the past, first one we'll talk about is the Canary Deployment. So you can create a new deployment YAML with the same app label, but additional Canary labels to test new functionality without bringing down existing production containers. So As long as you use the same app label, the load balancer will still send a percentage of traffic to those new Canary pods. Once the Canary containers have been validated as working, you can roll the new version in your standard deployment out and kill off the Canary. In this diagram, we have some new functionality we're testing with a free and paid version, along with the existing production payment methods. And we'll leave them running for a while to see how users are interacting with it before shutting them off. Another strategy we use often is blue-green deploys, or A/B testing sometimes called. Can be done in a similar way as before, where you set up a new deployment YAML. But you can also use a second load balancer in this scenario to test the new functionality and use DNS, either weighted alias or a different host name, hypothetically, to distribute traffic or slowly move onto the new app version. This diagram depicts the initial state with the public service pointing to the blue side and version 7. Then we do a rolling update on the green side to version 8, and we validate that version 8 with a smoke test and load test, and then cut over. This requires additional deployment YAML and, again, an additional load balancer, but that can be set up within the same EKS cluster. A tool that I see more and more now is something called Launch Darkly, a third-party paid tool I came across recently that helps in this area for configuration and reporting and has a wide list of functionality to help with this type of scenario. And then rolling deploys. This is probably the most common scenario where it replaces the containers one at a time, eliminating downtime and done with a single kubectl or Helm command. The intention here is to avoid downtime, and you should have tested in a non-production environment that new application or container prior to getting to this step. Now for some security strategies. So we strongly recommend using AWS security tools as they are available in your account. You just need to basically turn them on and configure them, especially CloudTrail. So the API access from kubectl to EKS is authenticated with kubectl and the IAM service roles. So EKS activity is logged in CloudTrail. So you want to make sure that that's turned on. KIM is an add-on that we use almost everywhere because it allows you to apply IAM roles to containers within the cluster and get very granular with that level of access. So for example, we'll set up a role to allow a certain type of container to get secrets out of AWS Secrets Manager that it needs for those environment variables to access, for example, the database and get that password securely and not store that into your Git repo. But I also need to mention the internal container security. The two types of scenarios there are, I see sometimes use a trusted repo where it's potentially a container repository that you're managing and vetting each thing. For example, like the Alpine or Ubuntu images that developers are grabbing before they start installing code. That then is sort of a master known entity that you've proven to be secured and doesn't contain any malware to start working with your code. The other more popular strategy is to do a security scan by leveraging any number of third-party tools to scan every container during the deployment cycle. And then a few more items here. Fargate's not yet available in EKS. It's only in ECS. That allows you to do this type of container management and orchestration without having to run those EC2 servers. It is slated to come soon, and we're hoping that is sooner than later. But with Fargate, I wanted to mention again the container size. So talk about security scans. You want to keep your containers small. I always recommend Alpine wherever possible because of the size. but you know, you have to do a security scan, and you want that scan to go quickly, so you want those deployments to happen fast. So you know, the larger container, the longer that scan is going to take. But also, a situation we saw recently is one customer was using Fargate and ECS with large containers in a web app, and that container had to do a Git pull on startup. And it was causing downtime during deploys because of the time it took for the container Git pull process to happen. So in that scenario, forcing adoption was not the right, you know, use case. You know, maybe they should have worked on, you know, using EC2 instances so that they could have cached images available within the cluster before it needed to, you know, basically start from scratch every time, which is a requirement in Fargate, as there's no permanent servers. Some additional learning references here I just had to mention because these are great tools. The Cubectl website is a great resource for learning. There's an interface there where you can actually issue kubectl commands for free to start testing out without having to have any infrastructure at all. And Kubernetes the hard way. If you really want to know all of the inner workings, this is a great resource to get a very detailed steps on how to deploy all the services and how they work together. And now we'll move on to the case study I mentioned. So we'll talk about YourCall Football. So YourCall Football is a mobile gaming platform that incorporated real football games with professional caliber players and former professional coaches. It set up a crowdsourced play calling. So the coach on the sideline would choose from a set of packages or of plays, and that 3-play package would then get sent to the mobile gamers at home or on the sideline and vote, and those users would then vote on the play that would get called on the field. The coach would get the winning chosen play, and it would be sent to the players on the field. If that play was successful, gamers would get fantasy points. It was anticipated a large number of concurrent users would be playing and voting, and no delays could be afforded in the voting or scoring or early end of the processing. So as you can imagine, one bad experience for a game user could be catastrophic if it went out to social media. So YourCall Football had built the application and the logic, but they needed help scaling and getting to the numbers and response time requirements that they had, as well as monitoring and managing the platform to meet these performance and reliability demands. So they reached out to Mission to help deploy Kubernetes. So this is a high-level diagram of how we deployed that. We proposed Kubernetes and went with it. We created the networking, the Kubernetes clusters, the databases, and the services with Terraform so that we could quickly make changes to scale up and down for the games. We used Aurora RDS, but most of the real-time session and scoring info was stored in the queue and in Redis. We learned that we needed to compartmentalize the 3 main microservices for the voting, rest, and user management so we set them up with 3 different Kubernetes clusters so that we could size and scale them separately. These clusters were built with COPS for the first season, as EKS was not released at that time. But for the second season, more recently, we did use EKS. And we've been able to collapse the clusters into one production EKS control plane, and we've been able to get a lot of efficiencies around that scaling and reduced management overhead. And we get just as good, if not better, performance now with that single EKS cluster. There's also an administration app that we created in Elastic Beanstalk to start and stop the game and the scoring functions. And we also built a Jenkins service to deploy the code using Helm again. And it also allowed the developers and SREs to execute Terraform through that Jenkins interface to scale up and down the environment on demand, because I mean, this infrastructure really only needed to be at scale during games. Outside of game time, there's very little usage going on, just people checking their scores. So it was critical that we didn't need to waste the money on hundreds of servers outside the game time. But it also allowed that interface in Jenkins to provide to those developers without giving them any AWS access. They could make those changes without getting into the console. And how Mission helped. So we iterated through many code and configuration issues to get to that 100,000 concurrent users in load testing. Pod density was an interesting one we came up against. We were using worker node groups and pod affinities with labeling to tie certain heavily used microservices that I mentioned to their own auto-scaling group. And we found each microservice used the resources slightly differently, and there was a number of pods per EC2 instance that was basically like a magic number for performance that we had to get the right instance type and amount of memory per EC2 instance to maximize that. Initially we tried to throw as many containers per EC2 instance as possible, but we found that wasn't always the best case quickly. And it's better to spread out and allow those kubelet management containers to do their thing without getting overloaded. That runs on each worker node. We landed on the R5 EC2 instance type primarily with the different larges and extra larges, and mainly for its increased bandwidth for the majority of them, but then we also are using T2s and some of T3s in some of those scenarios too. The RDS database was small, less than 100 gigs. So initially we sized it to that, but we found IO as a RDS as a bottleneck. And so we increased that disk to 1 terabyte, and we no longer saw that IO bottleneck because of the improved IOPS allowed on a 1 terabyte volume. And then we're continuing to help YourCall to continually improve. So, now that the second season's over, we're working on serverless, and we're going to be moving the API gateway, at least probably the voting and REST applications, into serverless and API gateway, so that we don't even need to run Kubernetes for those services, and we're going to be doing load tests there shortly. We're also leveraging Amazon's newish service, Amazon MQ, in replacement of the Rabbit service, and we've needed to redesign the deployment process in order to get that as well. So thank you. I think that wraps it up today. Thank you for your time. If you have asked any questions, we'll go through those now, but if you haven't, please feel free to pop them into the BrightTalk app and we can try to answer them here. Also, if you feel you have any more detailed questions, again, you can download the attachment around the Solutions Architect on Demand, or ask that question in the BrightTalk if you want to follow up, and we can reach out to you. All right, I don't actually see any questions in here. I'm new to this BrightTalk app, I apologize. But if there are no questions, feel free again to download that attachment if you need to follow up with us. But we will look forward to hearing from you if you had any questions. Thanks so much for your time today. There's a question there. Oh, okay, here we go. I did get some questions here. So can you talk about Minikube? There's one, that's a great tool to get developers up and running. Minikube, sorry, I wasn't sure if there were questions coming in. Thank you for asking. Minikube is a tool that is a quick to deploy. So for example, on your Mac locally, you can install Minikube and get testing on containers, and it works similar. You have a kubectl command to manage that. So if for example, you have a set of containers that need to work together within the cluster, Minikube is a great way to test and validate that functionality. Today we're working, there's another question about Azure and AWS. We do some work with Azure, but primarily we're focused on AWS today. We are working towards moving towards Azure, but today that's not in our I guess marketing set and product outline. But I know that Azure has their own Kubernetes service. I didn't cover that today, but I know that it's competitive in the marketplace. I'm sure that's not the answer you're looking for, but I apologize. We will be posting slides that will be available on our website. In EKS with EC2 instances, is there an idea of scaling the worker nodes themselves? Yeah, so I mentioned that a little bit, but you do need to set up triggers for the auto scaling group of the worker nodes. The pods will scale inside Kubernetes, and then the worker nodes need to scale separately. Those should be tied together, so the logic that you use to scale the HPA inside and the pods inside the Kubernetes cluster should scale and at least inform your scaling decisions around your EC2 auto scaling group. But that is a trigger that you will need to configure, outside the EKS infrastructure that's done within the Amazon either console or through Terraform. Ooh, that's a tough one. How to contain your ERP system. So, I mean, I talked a little bit about monolith systems. Most ERPs are that, where there's lots of functions within it. Microservices work a lot better within Kubernetes, but you can, do a lot within a single container and add a lot of functionality within it. So if you can containerize an application, that's sort of the hard part effectively with this. Once you have it in a container, getting it into Kubernetes is simple, but ERPs in their history have always been monolithic, Windows-based, which are turning the corner now with .NET Core and containerizing Windows, but it depends on the ERP largely and how it was built and if it's possible to containerize. There'd be a lot of effort in I think just understanding if containerization would fly with that platform. I don't know if there's going to be a video for it, but I think that we will try to make the slides available. That mainframe question we could try to follow up with, and as well as the ERP. I'd love to talk more about the details, and that's something that we could do with that longer SAOD question, and answer session that we can set up over a free hour of consulting. All right, any other questions out from the audience? Well, looks that might wrap it up this time. False alarm last time, but please, I'll leave this open for a few. If you still have some more questions, feel free to ask, but I'm going to stop the screen share now, and feel free to reach out if you have any further questions. I appreciate your time today. Thanks so much. Have a great day.